just like when you do work to stretch a spring, that energy that you did is not gone. When you lift something against gravity, the energy that you exerted against gravity is now stored. It's stored as gravitational potential energy. So let's consider just lifting an object that has some mass m, some height h. Okay? When you do this work, you exert a force, and we're going to lift this at a constant speed, so the acceleration is 0. So the two forces that are doing work here are the force due to gravity and the force that you exert. And those two forces are equal and opposite. And so the work done by you, or the work exerted, is equal to the force that you apply times the height that you lift them through times the cosine of 0, which is of course 1. So the work you do is equal to the force, but the force in this case is equal to mass times the acceleration due to gravity times the height. Now, the work gravity does, capital G there, the work done by gravity, is actually equal to the opposite of that, because it would be m times g times h times the cosine of 180 degrees, which is of course -1, so that's negative mgh. So the work done by gravity is negative mgh, the work against gravity is mgh, and this is what we call gravitational potential energy. Now, gravitational potential energy has to have a reference because that height that we move it through has to be measured relative to some 0 spot. It depends on where we put it. If it's the ground, then our 0 gravitational potential energy is the height of the ground. If we were up on a table, then if we measured this distance h, we would say that this has 0 gravitational potential energy at that distance. But if it were to fall down to the ground, then it would actually have negative gravitational potential energy. And that would mean we would have to do work on it to get it back to a gravitational potential energy of 0. So even though work and energy are not scalars, it does make sense to have negative work. And what's cool about this is it's completely path independent. It doesn't matter how we get to the top of a hill. If we have an incline that looks like this, or if we have an incline that is really long and looks like this, or if it was a flight of steps and each step got us a little bit closer, does not matter. The overall difference in height is h. So the amount of work it takes to get something from here to here is mgh. And we call that gravitational potential energy.